Good morning, sir.
Morning, Damian. How you doing?
I'm doing good, sir. I'm requesting about 10 minutes, sir, because I have to run and to take care of a little family matter. Quick and
All right, no
fast.
problem. All right, just be
Thank you.
careful. If you have to go on the road, just be careful.
Yes, sir. I'll be going on the road for temporarily, sir.
All right, work on come back
Thank you.
here.
Thank you, sir.
Come on. Okay, good morning, students. By now, you should have completed having breakfast. I am ready to begin, and I hope you are too. Trusting that you had a good night. I had a good night. I could do with a little bit more sleep, but guess what? I'm being very thankful. Up and well, and happy that I'm able to move around and my faculties seem as if they're intact. So thankful, hoping that you are also thankful. So as we are about to begin, we just want to give the Father acknowledgement to say, boy, Father God, big up yourself for sparing our lives, and to us to ask him for his guidance and protection as we go, not only through this class, but throughout this day, for knowledge, for wisdom and understanding. So clearing the table, breakfast should be finished by now, and we are going to go into we're going to go into the meat of the matter, the original purpose for which we're here gathered, and that is to do some calculus. So we looked at continuity. By the way, is there anybody that needs to share anything before we begin? Okay. So we looked at continuity. We looked at our piecewise functions last time around, and and by the way, how are we with the piecewise function? Are we okay? Do you think that you need a little bit more practice with it? Do you want to give a one question now before I go into the homework questions that I gave you? Hello? Somebody?
It's okay for me, sir.
Nice. What about the others?
Yes, okay for me.
Okay, good. So I'll move into our stuff because time is of the essence then. Great, I'm happy. All right, so I gave you some questions. I gave you this question for homework, I think. X squared plus 56x plus 15x plus 56. What values of x makes f of x discontinuous? Anybody did that? Okay,
Yes,
so okay, what values you got?
sorry, sir. I did all the questions, but I don't have my book with me right now, sir. Sorry.
Oh, you know. So we put them there. You there road? Please say yes to their road.
Yes, sir. I'm getting home, sir.
Okay. All right. Thanks, Laura. Is there anybody else that has completed the homework? Remember, time is of the essence. So when sir gives the homework, he expects him to be done. Anybody else? All right, answer the question one more time. Is there anyone else that has completed my assignment that I gave last week? So life is funny, and I'm going to tell you why. Go ahead, Dwayne. Let me hear what you say.
I'm saying, you gave the question. I think the working is on it. So
No, The working is not on it. The last sheet I gave you just had the questions. Let me tell you how life is unfair. Sir, I'm going to hold you accountable to send the notes as promised and the recording. You all know what happened to me last weekend. Was out of it, but I said, no, my students need the stuff. And through the discomfort, I started uploading the recordings. Maybe I have 1 or 2 more to upload, but I started uploading the recordings. I also sent you the notes, relatively short period of time. Could be the same date, don't remember exactly when I sent it, I can check. So I held up my end of the bargain. I held up my end of the bargain. And when was it, 19th? Right. So I sent the notes the same day of class. Class ended at noon, and I sent you the notes at 1:28 p.m. the same day. Only somebody said thank you. Somebody in the class said thank you. And and the work isn't done. Okay, so I have a solution. If you look in the participant list, you'll see quite a number of students this morning, as I would have put in a WhatsApp group shortly, that I invited some of my CAPE students who are actually doing this area just to come in to get some additional workup. If they weren't here, I would have paused and say, I'm going to do my homework. But guess what's going to happen now? I'm going to do the homework on our own without my solutions and hope and pray to God that they are correct and I'm not coming back to that. That is going to be your consequence, and I'm going to move on. So Laura, you do the homework, so you can't send it to me. So you're the only one in class that can admit that you did the homework, so you can send it to me. Right? And just Laura can send the homework to me. All right, so I'm gonna move on. We are all adults, and just as how you hold me accountable, I want to hold you accountable. And it's too early on the Saturday morning for me to get vexed, so we're not gonna get vexed. I'm going to forgive you and just move on, and you're on your own for that. And anytime I give you homework going on forward and you don't do it, I just get move on, and that is it, because I'm not going back to say, oh, let us, not doing it. Not going to give you the homework and then turn around and do it myself. No, negative. All right, so let us move into the average rate of change. And this is the last piece to complete Unit 3, and then I'm going to start Unit 4 today. I'm going to start Unit 4 today. And hopefully I can finish Unit 4 and move into 5. So average rate of change. Average rate of change. How am I going to do this? It's just by doing some examples. It says to determine the value of x for which g of x is undefined. But they don't know G sweet Jesus. But they never do the homework, so chances are you're not going to know how to do this. When does a rational function becomes undefined? That's my question.
So it's undefined when the denominator is equal to 0.
And you are able to answer me because you did the homework. Very good. Very good, Laura. So it is undefined. The rational function is undefined when the denominator is equal to 0. Very good. So why I gave you the activity last week is because I knew that I was going to be moving into the average rate of change today, that you're going to be using the same concept. So can you quickly work this one for me and tell me the value of x for which this function is going to be undefined? All of you, both CAPE and the business calculus students. Give me the value of x for which that function will be undefined. Hello? What value of x, students, to make g of x undefined? Diana, what value of x will make g of x undefined?
2/3, sir.
So when you not answer me, is Diane correct?
No,
Yes,
sir.
sir.
Back on it, it should be a negative.
It is a negative 2/3. Very good. And you know what is so funny about it? My solution is right here. And you all sat down and just looked at me. My solution is right here. All right. Okay, so let's go. So remember, when a function is undefined, or for the function to be undefined, I'm going to place the denominator equals to 0. The denominator is going to be equals to 0 because the denominator you can't have a 0 existing in the denominator. So I'm going to place it equals to 0, and then I will know if the function is undefined or not. As I said to you before, the only time you can speak of a function being undefined is when we have a rational function. For polynomials, the functions will be defined at all points. At all points, from negative infinity to positive infinity. But for a rational function, you will have a point of discontinuity somewhere. All right? So now this is what we need to look at now, the average rate of change of G on the interval. What is the average rate of change of G on the interval? -1, 2. Now allow me to introduce you to Mr. R, average rate of change. The formula is going to be f of b minus f of a over b minus a. So you want to find the average rate of change. Say, for example, you are a gas station owner. And with what is happening now with the little gas, Jesus, the I free to go road because I don't want to burn up my gas. Me now go say me a go road and now use the AC because me a save gas. Me a burn the AC same way because the sun warm. But I'm a gas station owner. And I want to find the average rate of change of gas over a period of couple weeks since the invasion of Ukraine by Russia. I can use my lower bound of the gas price to my upper bound of the gas price, and I can tell you what the average rate of change is going to be. When you hear the people them in the bank saying to you that the average selling rate of the US currency is XYZ, and the average selling rate of the Canadian currency is XYZ, and the average rate of change of the Caymanian dollars is XYZ. You know how them get that? Because there is a window that is allowed by all financial institutions to sell them US currency. So one financial institution may be selling the US dollar note at 149. I may go to another financial institution that's selling it for $151.25. I may find yet another who's selling it for 152. So you have to really move around in order to find a selling rate. Now, the BOJ gives them a range, and that range is determined by the financial institution. Now, the financial institutions will have to communicate to the Bank of Jamaica of their selling rate for the US currency. And then the Bank of Jamaica is going to use this formulation, the average rate of change, to tell you what is going to be the average selling rate of the US currency or the FX currencies, foreign exchange currencies, right? So this has a lot of applications. It is used heavily in business. You're a business student. It is used heavily in general operations. And you'll see further how this now becomes very useful to differentiation, because I can also use this in my differentiation, which is technically what it is that I'm doing. I'm differentiating. All right. So f of b minus f of a over b minus a, and you recognize what I did right here. This piece here is the first one in my close bracket is my a, and the second one in my close bracket is my b. So it's f of b minus f of a all over b minus a, all over b minus a. All right. Now, in order for me to find f of b, I'm going to substitute my b value into my function, get my answer, put it down. Then I'm going to substitute my -1 into the said function, get my answer, put it down. Then I'm going to say f of b minus f of a. And of course, I'm going to say b minus a. So I'm going to have 2 minus 1. So recall my function, this function here. Don't want to have to be going up and down. So recall my function. Anywhere in the function you see x, you're going to substitute 2. I'm going to substitute 2, and that is going to give me my f of b. That is going to give me my f of b. So let's go. And anywhere in the function I see, all right, let us do this first. I don't like how I wrote this one, but let us do it. So I'm substituting my f of 2 here. So anywhere in the function I see x, I'm putting 2. So 2 times 2 is 4. See it right here. 2 plus 2 times 3. 3 times 2 is 6. So why I put in 2 here? Because we're finding f of 2. 2 times 3 is 6. 6 plus 2 is 8. So I'm going to have my 4 over 8. So see it here. I am putting in my 2 into the function. Anywhere in the function I see x, I'm going to put 2. And then I'm minusing my f of b. So this is going to be f of b minus your f of a. F of a is anywhere in the function you see x, you're going to put -1. So it's 2 times -1 all over 2 plus 3 times -1. Let me just fix up this. I don't like how I did it. All right. So it gives me this in 1. And then wherever in the function I see x, I'm going to substitute -1. And it gives me this when I would have substituted in it. All right. So if I want, I can put, to make this look a little better, I can put this as 4/8. And I can do this to tell me that it's going to be 3 times -1. And that's 2 times -1. And that is going to give me -2 over -1. All right. So this 2 times this -1 is -2. And 3 times -1 is going to be -3. Why do I have a +3 there? -3. And -3 plus 2 is going to be -1. All right. So that is going to give me this 4/8 minus -2 over -1. Of course, we can break it down, right? And then now I'm going to subtract the fractions by finding the LCM. And of course, what I'm going to have when this is broken down, I'm going to have 4/8 is going to be the same thing as 1/2. And -2/1 is when I divide two negative numbers, I'm going to get a positive number. But this negative sign still remains. It's going to be negative, and that's just going to be 2. And 2 can be written as 2/1. All right. And when I find the LCM is 2.5 minus 2 is going to be -1/2. So this is going to be my -1/2 there. And what I'm going to have thereafter is going to be my b minus a. What is b minus a? It's going to be, what is b? 2 minus -1, which is going to be equals to 3. So what I'm going to be doing now is to say -3/2 divided by 3, which is this. -3/2 divided by 3, and it's 3/1. So of course it's going to be -3/2. When I divide in two fractions, multiply, invert. So this 3/1 becomes 1/3. Those two cancel. So I'm going to left it -1/2. So my average rate of change is going to be -1/2. So just remember, however you want to do your calculation, I did it this way because I wanted to show you step by step. Just remember, your average rate of change is going to be your f of b minus your f of a over b minus a. Your average rate of change is going to be f of b minus f of a over b minus a. Evaluate your f of b, put it down. Evaluate your f of a, put that down too. And then you're going to subtract your a from your b. B minus a, and you're going to combine all of them together in order for you to do this. All right. Let me just tell you something here with calculus. Either you're doing business calculus, anything that says calculus, you have a lot of what we call formulas. You have a lot of formulas, and you have to use those formulas in order to give you your desired results. So you have to use those formulas in order to give you your desired results. All right, so just remember your f of b minus your f of a over b minus a. Let me walk you through quickly with another solution. Let me walk you through quickly with another solution. And it says the average price for a ticket to a concert for selected years is in US dollars. In 1987, the price was $391. 91, it was $421. 95, $435. 99, $506. 2003, 602, 603, 2007, 688, and 2009 is 750, right? So you recognize that, boy, the price, like it'll go up and on. Yeah, man, it'll increase over a period of time, sir. What's the winner of 1988? Okay, that's fine. 1988 could be the same price as this, but 1991, so it'll move, so it'll move, so it'll move. It says find the average rate of change of the ticket price with respect to time. So I'm trying to find ticket price with respect to time over the period 1987 to 1999. Explain your results. 4 marks. Wow. But sir, you just told us it's f of b minus f of a over b minus a. And that's where you find the average rate of change. And the question did ask us to find the average rate of change. So if you see what the question is asking and you know the stuff, you're good to go. F of b minus f of a over b minus a. Let me see how many of you are listening. What is my f of b value? Can anybody tell me what my f of b value would be? What is my f of a value?
Sir,
Yes, sir.
could it be 21 and 17.53? Not sure. Yes.
I'm not going to be in it with one this morning here, so do me a favor. Look at the answer, look at the solution to that, and I'm going to give you a couple of minutes. So come back.
Yeah.
All right, just checking. Are you guys ready to speak to me now? Okay, I guess not. When you're ready, let me know, please.
Yeah, yeah, sir. I'm ready to go.
I'm not hearing a soul. I asked a question and I waited about 5 minutes before somebody came and asked me a question. And it's too early in the morning. So, yeah. All right. Can you see what it is that I've done? How I arrived at my answer here? Any
Sir.
questions? Why I use what I use?
No, sir.
Sir, is it the starting point and the midpoint you use?
No. Read the question. What the question says. From which year to which year?
Oh, I see what it says. Yes, sir.
Mm-hmm. So the question said, you know, say from 2009 to 1987, it gave you a period of years, and it did say from 1987 to 1999. So those are the things that I'm looking at in question. So I'm looking at 1999, 1980. So ticket prices with respect to time. Because I'm saying ticket price with respect to time, that means ticket price is in the numerator and time is in the denominator. And time is in years. So the highest one is 506, 391. Says it'll be 506 minus 391 over 1999 minus 1987. And I'm going to have 10 US cents. My interpretation says 100 tickets increased by 10 cents each year from 87 to 99. From 87 to 99. So when you're doing your analysis, that's what you can write. So why 87 to 99? Because those are the years that we're looking at. Those are the years we're looking at. Those are the years we're looking at. Another example. I'm going to ask you to do this one for me. All of you, including the CAPE students, because you get points of discontinuity also. So I want all of you to work on that example for me, please. Thank you. How far are we?
Sir, part 2.
All right, cool. Are we finished now? Are we finished?
Well, me, no, sir.
How far are you?
I think I'm making an error with I, so I'm just trying to clear up something.
All right, hurry up. It's only 2 marks and it's sitting hard. Only 2 marks. 2 more.
Sir, I tried something. I'm not sure if that's the right answer, but
Okay, what did you get for your answer?
all right. For part one, sir,
Mm-hmm.
I got two values of x, sir.
Mm-hmm.
I got
Go ahead.
x equal 1 or x equal -6.
Is she correct?
Yes, sir.
Yes, sir.
And have you calculated the average rate of change? What's the average rate of change of age? Somebody, I know some of you need to just answer me, man, and stop drawing the class. And if you have you done part two? And if you have you done part two? Shanti, have you done part two?
Yes, sir.
What's the answer?
Sir, I have 31 over 432.
31 over 432. Anybody agrees with her? All right. Let me just fix this. So you all agree with this -6 and positive 1?
Yes, sir.
All right. And I got, what does it say? Got 431. You got Shanti?
432.
All right. So remember, it's f of b minus f of a over b minus a. F of b minus f of a over b minus a. So I'm evaluating f of b, which is f of 3. Anyway, in the function I see x, I'm going to put 3. So it becomes 7 times 3 squares minus 8 over 3 squares plus 5 times 3 minus 6. Everybody got that substitution correctly?
Yes, sir.
And 3 squares are 9, and 9 times 7 is 63, minus 8. 3 squares are 9, 5 times 3 is 15, minus 6. 63 minus 8 is going to be 55, yeah. 9 plus 15 is going to be 24. 24 minus 6 is going to be 18. So my h of 3 here is going to be 18. 55 over 18, sorry. Let us look at f of a. F of a, when it's equals to 0, anywhere in f of x, I see x, I put 0. 7 times 0 squared minus 8 over 0 squared plus 5 times 0 minus 6. Not because I'm moving to 0, it means that the function is going to be 0. You have to substitute and double check. All of this goes to 0, so I'm left with -8. That goes to 0, so does this one, so I'm over -6. So -8 over -6 is my h of 0. Remember, it's f of b minus f of a over b minus a. So I must also find b minus a, and 3 minus 0 is going to be equal to 3. So now that I have all components of my f of b minus f of a over b minus a, I just need to put them together. So I'm going to say 55 over 18 minus 8 over 6. 55 over 18 minus 8 over 60. So I get 8 over 6 because this here, when I divide two negative numbers, I get a positive number. So it becomes positive 8 over 6. So why don't we break it down from now? Nah. So when I do this, my LCM is going to be no, something wrong right here. So Shanti, you may be right. You may be very right, Shanti. I don't know what I did right here, so. But I know what's on the screen is very wrong. No, I'm not. I'm correct. 6 going to 18, don't.
Yes, sir.
6
You're
3s are 8.
correct.
Yeah, I'm right. You're right. Early morning, I don't have my coffee. That's why. So the LCM is 18, and that's why I didn't break it down here at this stage. So my LCM is 18. 18 to 18 goes one time. Let me do it so you can see what is happening. LCM is 18. 18 into 18 goes one time. 1 times 65 is 55. And 6 into 18 goes 3 times. And 3 times negative 8 is going to be negative 24. And 55 minus 24 is 31. 55 minus 24 is 31 over my 18. So I'm putting up this answer somewhat to say that my average rate of change now is going to be 31 over 18 divided by 3, which is this 3. And it's the same thing as 3 over 1. So it becomes 31 over 18 multiplied by 1 over 3. And 31 times 1 is 31. And 18 times 3 is 54. So I'm going to get this as my fraction, and my decimal is going to be 0.57. Tell me if you agree with me, please.
Yes, sir.
Yes, sir.
Can you see your error, Shanti?
Yes, sir.
All right, cool. Is there anyone in the class that is not following what is happening here?
No, sir, following.
Okay, great. Oh, oops. That's the end of the question. That's the end of unit 3. Unit 3 is pretty short. F of b minus f of a over b minus a. Just go ahead and substitute your f of b into the function, put it down. Substitute your f of a into the function, put it down. B minus a, put it down, and then combine all of those together, and then you are finished the question. It's done. Finito. Finito. And without wasting any time, I am moving over into my differentiation. I'm moving over into my differentiation. Now, Cape students, I want to pay keen attention to this, though I will go through this with you on Monday, God's willing, but I want you to get a jump start. Business calculus students, this is a must-have. This is going to be on your mid-semester exam. Average rate of change is also going to be on the mid-semester exam. Piecewise function and limits will be on the exam. I don't have the dates of the mid-semester, but I can tell you that the mid-semester was already written. Let's go. I am differentiating 2x squared minus 5x plus 3 from first principles. When the man them give a question, Cape and Biscal, on the exam paper, when they say to you, differentiate from first principles, if you use any other method other than first principles, you are going to get 0 mark. Any other method other than first principles, you're going to get 0 mark. 0, 0, 0, 0, 0 mark. Hold on a minute, please. Sorry about that. So let's go now. First principles. So I was saying to you, oh, come on, you know that I'm in a class. Oh, hold on. All right. You see, when you have senior people and you trust senior people with cell phones, that's what happens. Let me put this on ticklish. Ticklish. All right. So now it's on ticklish. It shouldn't ring out again. All right. Sorry about that. Right. So I was saying to you, now when we're looking at first principles, we have to make sure that we answer the question from first principles. If we do the question otherwise, then sir, the question can be done otherwise. Absolutely. Absolutely. But if you do the question otherwise, other than what they ask you to do, you are going to be in problems. Serious problems. All right? So let's go. When you're doing calculus, you have many different formulations. Jesus, Father. But guess what? The formulations are so nice. They're easy to remember and you're good to go with it. We'll just look at f of b minus f of a over b minus a. Now we're going to be looking at the limit as h tends to 0 of f of x plus h minus f of x over h. Whoa, sir, me not seeing no h in there. Where h come from? Thanks for asking. My h is my small change. So we're looking at the rate of change of y with respect to x. That's what we do when we differentiate. we're looking at the rate of change of one variable compared to the other variable. We're looking at the rate of change of one variable compared to the other variable. Now we're looking at the rate of change. So therefore, there's going to be a change in what it is that we're doing. And that change is going to be denoted by my h. When I incorporate that change, I am then going to subtract my original function. That explains my f of x. So when I appropriate the change to the function, I'm going to then take out my stuff. Think of it this way. And I gave my CAPE students this very example last night. Think of it this way. I'm cooking soup today, chicken foot, pumpkin. I'm going to drop a couple of bits of pimento seeds in it. I put in the pimento, but guess what? When I share the food, I'm not going to share to the pimento. I'm going to put scallion and thyme in there. But when I put it in there, I'm not going to share the food with it. I'm going to make sure I take it out. And if you share my food with it in there, I'm a buck up on it, I'm not going to want to eat no more. Especially if I have a nice chicken foot and dumpling in my mouth, I'm going to bite the pimento. I'm going to spit out everything. Nope. Turn me off. Don't want it anymore. So how that come in? Same thing. You put in something into the function, then you have to take it out because it does its purpose. It has fulfilled what it is that it was supposed to do. So now it is that we're going to be working with our f of x, minus our f of x from it. And then we're going to be dividing it by h. Because we're finding the limit as this h as my incremental change goes to 0. Okay, sir, let me see what it looks like. All right, no problem. Watch me. Look at how I'm going to find my f of x plus h. Anytime I call a x, I put a plus h. Anytime there is a x, I put a plus h. Anytime there is a x, I put a plus h. Anytime there is an x, I put a plus h. Watch me. See the function here? F of x plus h is what I'm going to do to get this. 2, see our x here? So it's going to be x plus h all squared. See right here? So x plus h all squared. So after I call the x, I have to put the h. Minus 5, see x here? So it's going to be x plus 8. See here? So minus 5, x plus h. Plus 3. We don't have no x, so we don't put no x plus 8. So we just put the plus 3. And then now again, minus all of f of x. So minus, and say f of x here, 2x squared minus 5x plus 3. See here? So 2x squared minus 5x plus 3. You see, because the minus in a polynomial, I have to put it in parentheses. If I were doing just one term, I didn't have to put it in parentheses. But because I'm doing multiple terms, I have to put it in because this negative sign here governs this term, and this term. So it governs all the terms. All right. So this is how I get my f of x plus h. Watch me again. Every time I call that x, I put a plus h. So this is 2x, 2x plus h all squared. This is a minus 5x, minus 5x plus h. This is my incremental change. So I'm looking at my incremental change from 2x squared to 2x plus h all squares. I'm looking at my incremental change from negative 5x to negative 5 times x plus h. And of course, my plus 3. All right. So let's evaluate. See, I put it up here. X plus h all squares is the same thing as x plus h times x plus h. And when I multiply, when I distribute this 2 is written back here because BOMDA says that I work my brackets first. BOMDA says I work my brackets first. So x times x is x squared. X times h is hx. Oh, Lord Jesus. All right. See me my copy and paste here again. Just love it. So x plus h all squares is the same thing as x plus h times x plus h. Now watch me. And I want you to look carefully at it. I have been struggling with both groups, not just calculus, but the CAPE students also with their factorization. All right? So I really want you all to get your factorization, how it is that you're supposed to be getting it. This x times this x to give me x squared. This x times this h to give me xh or hx. This h times this x to give me hx again. And this h times this h to give me h squared. Now, if I look carefully, hx plus hx are the same term, so I can add them. And in adding them, I'm going to end up with 2xh. I'm going to end up with 2xh. 2hx, same difference. 2xh, 2hx, same difference. All right? So look at what I'm doing now. Is when I reach this x plus h all squares, I'm drop it in right here, so because I now remove my exponent. Now remember, BOMDAS says I do my brackets first and then everything else after. So I had to do my brackets first before I multiply that 2 out there by it. I can't multiply the 2 first. That's illegal. So I had to do my brackets first. All right? And then no, I'm just rewriting the stuff. Minus 5x plus h, same thing, plus 3, same thing. Minus 2x squared minus 5, same thing. All right? Then now I'm going to be removing all my parentheses from this line to this line. 2 times x squared is 2x squared. 2 times 2hx is 4hx. 2 times 2h squared is 2h squared. Minus 5 times x is minus 5x. And minus 5 times h is minus 5h. Plus 3 stands alone. Watch me. This negative sign, which is a negative 1. See, I have it up here, so it's a negative 1. Multiply by a positive 2x squared, give me a negative 2x squared. The same negative 1 multiplied by a negative 5x gives me a positive 5x. And this negative 1 times a positive 3 will give me a negative 3. All right? Very important. So technically, when you distribute this negative sign over these parentheses, all the signs in here is going to change. So this is plus 2x squared, it becomes minus 2x squared. This is plus 5x, because negative 5x becomes positive 5x. Positive 3 becomes negative 3, all over h. Now, remember I said to you that I'm subtracting my f of x. All my f of x must be cancelled out. If it's not cancelled out, something is wrong. I put in the pimento. I put in the scallion and onion and thyme. I'm a parsley. I may not be able to take out the parsley and the onion because those would cook out. But the pimento now cook out, the thyme now cook out, and the scallion now cook out. So I need to remove all of those. When you're going to the hotel industry to work, what they do, they have like a sieve, like a strainer that can close. One big something, and then just drop all of that, all of the seasoning, then just drop it into one of that and put it down, and it have a little chain where just cook it on the pot, and it bubble and it bubble and it cook and it cook. So when you finish cook now, you just hold that chain there and you just take out everything. So you know, say every seasoning where you put in the pot will come out. Because when you serve one little spoon of a clam chowder for $15 US, you can't make no seasoning, it have to smooth. All right. So that's what it is that you're doing. All right. So when I do that, I'm going to have all of this here. So I have 1, 2, 3 terms in my original f of x. All those 3 terms must be cancelled out. Let us check to see if they're cancelling out. 1, 2, sorry, the 2x squared, see here, this 2x squared, negative 2x squared will be cancelled with this 2x squared up here. Okay, so that's 1 term. This positive 5x will cancel with this negative 5x. That's 2 terms. This positive negative 3 will be cancelled with this positive 3, 3 terms. So all my terms did cancel out. What do I have left? 4hx plus 2hx squared minus 5h. See it right here, so over h. I'm about to begin my limits, but I can factor out something here first. Because if I don't factor out my h here, what do I have? Let me hear you guys. What do I have if I don't factor out something here? So if h is equal to 0 right here, what do I have?
Indeterminate.
Say it again.
Indeterminate.
Very good. I'll have the very good. I'll have the indeterminate form. I'll have the indeterminate form right there if I don't factor out, right? And the indeterminate form is, well, in this case, is, of course, is going to be 0 over 0. So I'm going to have the indeterminate form here. And so therefore, I have to do a factorization. And that's what I'm doing here now. So you see all that we have done before, and this is why I get annoyed when I give you homework and you don't do the homework. As you would have seen, me move into average rate of change. It meant that you needed that prior knowledge of doing some work that I gave you last week that I didn't do. Me teaching you limits. You needed the prior knowledge about indeterminate forms, so it is that you can move on from here. So now that the form is indeterminate, we now need to find a way, either rationalization, simplification, or factorization. And we recognize that h is common to the 3 terms in the numerator. So we're going to be factoring out our h. And in factoring out our h, we are going to have h, open bracket, 4h plus 2h minus 5. Now the h is cancelled, and I'm left with this polynomial. Whoa, sir. But the limit of the polynomial always exists. Absolutely. So as h tends to 0, I'm going to substitute my 0 into the function. So it now becomes 4h plus 2 times 0 minus 8. See it right here, so? And 2 times 0 is 0, so I now have 4x minus 5. Let me ask you, 4x minus 5, I'm finding the limit as h tends to 0 of 4x minus 5. What does this 4x minus 5 now becomes? H is tending to 0. What does this 4x minus 5 now becomes? Why I have 4x minus 5, here's my answer. That was a hint. Tell me. When I find the limit of something and it comes back to the same something, what is it?
Rational or
Constant.
constant.
It's a constant. So this now becomes my constant. Sir, how 4x must become a constant? Because h is tending to 0. H is not tending, x is not tending to 0. There is no h in this function, so this function now becomes a constant. So the limit of this constant is going to be the constant itself, which is going to be 4x minus 5. And that's how we would have done it. All right? I'm going to give you a couple of minutes to look through. I'm reducing it so you can see what is happening. You may have to zoom in, but I'm reducing it so that you can see what is happening with the question. And the question, I believe, starts there. Yeah. So look at that for me. I'm giving you a couple of minutes because this topic finished. All that there is to be done now is you working the questions and making the mistakes and me correcting you. All right. So I give you about 3-4 minutes to look through this thing here, and then we start working on some questions on our own. Start now, please. All right. Are there any questions regarding this? Are you understanding? Is there something that you don't see?
Well, I'm still going through, sir. Hold on, sir.
Okay. All right. Sorry to rush you. No, okay. I'll give you some more time. Shanti, I saw you going to say something. Okay, Shanti?
Yes, sir. I'm fine.
Nice. All right. Do me a favor. Coming to you. What's that doing? Coming to you. 1 minute, please. 1 minute. 1 minute. 1 minute. I am going to, for those of you who are finished, I'm going to paste a question, a new question right here at the bottom of the page. A new question at the bottom of the page. A new question at the bottom of the page that I'm pasting right here. For those of you who are finished, I want you to do this. So of course, this is going to be your function, your new function. So those of you who are still working, this is going to be your new function, and you can use this to guide you in doing this one. Start from it, please. I'm stepping away for 2 minutes. How we stay?
Finish, sir.
Woo! Nice, Shanti. Shanti, tell me what it is that you got for your answer first.
Sir,
Sir,
finish.
8x plus 3.
Okay. Manisha, what you get?
Same thing, sir.
Dwayne, what you get?
Same thing, sir.
Very nice. The three of you are correct. Oh my gosh. This is what I love, especially when I'm missing sleep in the early morning and my students are learning. Very nice. First principle is done. It is finished. Now, I don't, hold on, no, let me ask you a question because, Laura Lee, I don't like your, I don't like your stance in class today. You're not all 100% my student today. What is happening? Something is bothering you, Laura. Something isn't right. You are not. Where is Tess? Oh man, this is not going to right. Welcome, John Mark. Damien, are you back?
Yes, sir, I'm back, sir. Yes, sir, I'm back.
Okay. Did you get that for 8x plus 3 for that answer?
Yes, sir.
Nice job. Very nice. Diana, how you stay?
Sir, I wasn't finished.
All right. Hurry up and finish up, please. I'll give you 2 minutes. 2 minutes. 2 minutes. All right. Aniki, how you stay?
Yes, sir. That's what I got.
Very nice. Now, I don't know if you recognize, but I get the energy when students do their work. They don't have to get it right, you know. But it's just that they made an attempt. And so they sit down there and not do nothing. That's when you and I don't get along well. That's when you and I don't get along well. But you see, the moment you try something and you try and you buck up, not a problem. I will help you find your way. But I just don't like a passive learner. You sit down there and, okay, I got him say, all right, I'm just go do that then. I want you to be able to work with me. So this is very good. Now I feel like I had my coffee and I feel energized. All right. So I'm going to move the screen from here. I'm going to bigify it. And I'm going to go to where we were. It's supposed to be 2hx. I saw that error when I was doing the stuff. So that's what the answer is supposed to be. What I did this time was to color code it. I'm missing a color. Oh no, I'm fine. I color coded it this time so that you can see the ones that I'm removing. All right, and then 8x plus 3. All right. Now, understand about it? Let me see how bad you guys are. And bad in this way is a good bad. You have bad, bad, and good bad. Eh? This is a good bad one. Now, let me just warn you off on something. There's a negative sign in front of this x squared here. It's a negative 3x. Very important. There's a negative 3x. So let me just warn you off on this one here. And this negative 3x, you have to make sure that you take account. Anybody who gets this right is a student who is very good with their algebraic skill. That's all I'm saying. Start for me, please. You see, UK students, I'm going to teach a class come Monday, no? Because I'm going to have it locked. John Mark, start for me. Honesty. All right.
Yes, sir.
Finish?
Yes, sir. Yes, sir.
Woo! Okay, Manisha, what you got for the answer?
Sir, negative 3x minus 2.
Okay, negative 3x minus 2. All right. Shanti, you say finish. What you got for the answer?
Negative 6x minus 2.
Okay, Dwayne, you
Yes, sir,
finish?
that's what I got.
Okay, Anika, very good.
Not
Dwayne, wait,
finish it, sir. Not finish it. Not finish.
nothing said. All right. Diana, Damian.
Not finished, sir.
Still
All
working,
right.
sir.
All right. Okay. All right. All right. I'm not rushing now. Go on, take on the time. I won't tell you if you write it, but go on work.
Sir, negative 6x minus 2.
Very good, John Mark. All right. All right. 2 more minutes and then we'll come back.
So I'm finished now.
All right, what you got for the answer?
Negative 6x minus 2.
Only getting better and better and better at it. Now, you recognize what is happening? I am silent and you are doing the work because there's nothing more to do. I've already laid a foundation. It's now you to complete this task. Is there anyone in the class that is struggling or that has not gotten this negative 6x minus 2? Sorry, Manisha, you said negative
Sir,
3x.
I mistake I did make. I never
Okay.
multiply the 3 by the 2.
The 2, I know. I figured, I knew that. I knew exactly what it is. And that's why, remember, at the start, I said to you that remember that there is a negative 3 outside there. Very important. Now, you said something a while ago, Manisha, that I'm going to come to before the end of this class because I'm not going to spend much more time on this. I'm going to give you a few more questions, but you said you never remember to multiply the 2 by the negative 3, and that's fine. And we're going to come to that. Is there anyone, just hold on to that, Manisha, because I'm going to come back to you with that. Is there anyone else in the class that has a difficulty? I mean, I'm not going to be calling you out by names, you know, there are many of you in the class. Are you okay? All right. Oh, here's something else. You see me having this thing here, let, supposed to be here. Sometimes they give you the function and they don't give you the stuff into it. So you don't need to let the function be equal to that. Very important. I saw that and that's why I left it like that because I want you to see. So you don't need to let f of x be equal to that. So you can't just move from here to here. So you have to name the function. It's very important. And the same thing here. You have to let, you have to name your function. All right. You have to name your function. So I'll just go and put in the rest for my stuff. Okay. Negative 6x plus 2 minus 2. Was that there? Yeah. All right. I have a do now for you. I have a do now for you. And guess what? The aim of in giving you so many of these questions for you to get better at it. And quicker, so it's not 5 minutes this time. All right. Hurry up. On the mark, get set, go.
There will it be y equals 14x minus 3?
Y equals what?
14x minus 3.
Okay, Aniki. I hear you. Is there anyone in the class that agrees with Aniki?
That's what I
Yes,
got.
sir. Yes, sir.
Boy, I tell you, it look like you guys, my kids students have to come to class on a Friday, on a Saturday morning. 14x minus 3 is correct. Is there anyone in the class that is not following?
You must put back the y, sir.
Let's put 14x minus 3. Sachel, are you okay? Shaquille, are you okay?
Yes, sir, I'm good.
Who was that? That was Shaquille?
Yes, sir. That's what I got on.
That's what they got, Sachel?
Yes, sir.
Okay.
I didn't hear you, Sash.
Yes, sir.
Okay, great. I'm gonna remember, you know, today's an exercise day. Here goes another. We're going to do about 2 more of these after this. No, and what I'm going to do, I'm going to catch you guys. After this one, I'm going to catch you. The thing's so smart. All right. Do this one for me quickly, and then I'm going to answer 2 questions. All right. Continue. Dwayne, Damian, make sure you're there, you know. John Mark, make sure you're there.
Yes, sir. Yeah, yes, sir. Follow it, man.
All right, good. Andrew Han, you are not my student today. I doubt it even on you to say good morning, sir. You have not spoken to me since morning.
Good morning, sir. I actually did, sir, but you probably didn't realize.
Okay, then. All right. Forgive me. Morning, Papa. All right. You follow it.
Morning,
All right.
sir.
Okay. Nice. Good. 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 All right. Start again, guys.
4x plus 5, sir.
Sorry, what's the answer?
4x plus 5.
How the rest of this thing?
Yes, sir. X plus 5.
Agree, sir.
Yes, sir.
Did you say x? Did you say x plus 5?
4x plus 5.
Oh, okay. Me just a wonder. It's very good, guys. Very good. I want you to try that one for me. X cube. I want to try that one, x cube. At 11 o'clock, I want to switch my focus and go to the other section of differentiation. And then I will just continue doing some of these as time goes on. You see, it's recognized I have quite a bit of examples. I'm at example number 9, and I think we did up to example number 5. So I can give you the others to do. Try number 9. One thing I can guarantee you today is that none of you will be able to cross it. None of you will be able. Andrew, Anike, Shante, Damian, Diana, Dwayne, John Mark, Laura, Manisha, Natalie, Nathania, Sasha, Shaquille, none of you will be able to cross this. Prove me wrong. Anybody give up yet?
No, sir.
All right. You bad. All right. Look how you soon have to give up. Look, watch it.
Sir. Sir.
Is it time for you to give up? No?
Is 3x correct?
Sure. You just cramped my store while I got Sasha, David. Sure. Yes, you're correct. Very good, sweetheart. Proud of you. But my question to you is, did you use first principles?
Yes, sir.
Very nice. Shante, Dwayne, Damian, John Mark, Laura Lee, can you unmute for me, please? Something is happening to this student of mine this morning. Laura? Laura Lee. Can you call me on WhatsApp now, please? Call me on WhatsApp. I'm saying, call me on WhatsApp, Laura.
Yes.
Okay. Andrahan, what say you?
Sir, still working on it.
Okay. Dwayne, what say you?
I tried up to a point.
That one they have the other manners. All right. Damian, come talk to teacher.
Sir, we're still trying, sir.
You're still trying something. All right.
Yes, sir.
I give you 2 more minutes. Go on, try, man. I knew this was going to bore you. That's why I'll give it to you. I soon come. Dwayne, talk to teacher. Any closer? Andrahan, how you stay? Any closer?
Sir, no, sir.
Okay. Shante, any closer?
Yes, sir. I got the 3x squared.
Very nice, very nice, very nice. All right, I'm gonna help you guys. I don't want anybody to leave my class believing that I don't believe in you. When I say to you that nobody's going to get it in, it is just reverse psychology. I'm going to give you 5 minutes to look through my solution. You may have to zoom in. I'm going to give you about 5 minutes to look through my solution. It's a whole lot of work. So when I say to you that nobody's going to get it, is that I know it's a whole lot of work, and I know some of you are going to make some computational errors. Kudos to those of you who got it. Very nice. Proud of you. Take about 5 minutes, look through, and when I come back to you, then you can ask me your questions. All right? All right, guys. Dwayne, do you see where it is that you made the error?
Yes, sir. Yes, sir.
Okay. Are we okay now? Sasha, okay? Everybody else okay with what it is that I have done?
Yes,
Yes,
sir.
sir.
Yes, sir.
Very nice. So I'm going to move on from here, and I'm going to move into some rules of differentiation. 10 past, we have 50 minutes left, and I'm going to maximize the time as best as possible. Now, I'm looking at one of the rules for differentiation, and this rule here is called the chain rule. Fret not, the additional questions that I have here that I did not give to you, I can give them to you when I circulate the handout today. Cape students, I may not circulate it to you. Let me think about it. Right, I may not circulate it to you because Cape students, remember, you will have to do the differentiation of trigonometric ratios as well. The business calculus students don't need to do trigonometric ratios. So what we are doing here with the business calculus students, you will do this, but you will do a little bit more, well, a whole lot more than what the business calculus students will be doing. But this is very important to you. So I won't necessarily send this off to you now. I just wanted to give you a jump start, and I'm really very proud of all of you Cape students here present because you're understanding. So just imagine when I come to your class now and give you some more stuff, how much more you'll understand. So very good. All right, so all of you know, let's go. So the chain rule, y is equals to x to the n. Y is equals to x to the n. When I'm finding dy by dx, which is the rate of change of y with respect to x, when I'm differentiating, I'm finding the rate of change of y with respect to x. This n is going to come in front of the x, see it right here, so, and then I'm going to subtract 1 from the power. The power becomes a coefficient, and the power is then reduced by 1. The power becomes a coefficient, and it's then reduced by 1. Manisha, I told you I was going to come back to you. Look at this example, all of you. Manisha, soon come answer a question. Look at that example and see if you can see it. Talk to me now. Y is equal to x cubed. That's the last question we did using first principles. Y is equal to x cubed. You see how quickly I could have done this? By just multiplying this 3 in front of the x, the power becomes a coefficient, and then the power is reduced by 1. So 3 minus 1 is 2. So we're going to get 3x squared. Everybody see this?
Yes, sir.
Yes, sir.
Good job. Excellent. Let me go again, because if you catch this, you're good to go. Now, this method is much easier than the first principles method. By far, it is much easier than the first principles method. When I ask you, I tell you, much easier than the first principles method. But you have to know the first principles method. The man then can be mischievous and say to you, by using the first principles, do this. But if them don't tell you use first principles, don't use it. First principles is way too hard for you to go do that. And when I say hard, not difficult, hard that you can't do it, but it is tedious. Tedious. All right, so let's go. X to the n, y is equal to x raised to the n power. X to the n, dy by dx is going to be equals to n, x to the n minus 1. N, x to the n minus 1. I'm subtracting 1 from the power. You always subtract 1 from the power when you are differentiating. You always subtract 1 from the power when you are differentiating. You always subtract 1 from the power when you are differentiating. Always subtract 1 from the power when you are differentiating. Always subtract 1 from the power when you are differentiating. Let's go. What do you think this answer is? Did we do this before? Negative 3x squared minus 2x minus 3 from first principles? And what did we get for our answer?
Negative 6x.
Negative 6x minus 2.
Absolutely. Let's go. Monisha, so this is what I was saying to you. When you said it to me a while ago, Monisha, I was like, okay, good girl, I think. You did say, sir, I forgot to multiply the 2 by the negative 3. And that's exactly what we're doing. This 2 multiplying by the negative 3 is going to give me negative 6. I'm reducing this power by 1. See it here? It's 2 minus 1. Even though you don't see this x, this 1 that is being raised to power x, you know that there's a 1 up there. 1 times negative 2 is negative 2, and 1 minus 1 is 0. Anything raised to the power 0 is?
1, sir.
Is 1 every single time. Anything raised to the power 0 is 1. All right? And watch me now. the differentiation of a constant is equals to 0 every single time. The differentiation of a constant is equals to 0 every single time. The differentiation of a constant is equals to 0 every single time. The differentiation of a constant is equals to 0 every single time. The differentiation of a constant is equals to 0 every single time. You see how many times I say it? It's not that I'm trying to remember it, you know. I'm trying for you to remember that the differentiation of a constant is equals to 0 every single time, barring none. The differentiation of a constant is equals to 0 every single time. Do you understand that? You get that?
Here
That
is
is a
loud and
question.
clear, sir.
All right, clear as mud. Got you. So when I differentiate -3, I'm going to get 0. So why is the differentiation of a constant equals to 0? Can you just explain to us this one digga time? I'm more than happy to do it. You know that this is 3x squared. Then this is, sorry, let me not say 3x squared, but let me say this is x squared. Then this is x to the first. This one going to be x to the 0. Because anything raised to the power 0 is 1. So this x to the 0 is 1. But we don't normally write x to the 0. But for emphasis, I'm writing it now. Because this 0 times -3 will give me 0. And that's how we get the differentiation of a constant to be equal to 0 every single time. So my answer is going to be -6x minus 2. Can you just look at this and differentiate this on me, please? 2 times 4 is?
A.
All right, so this becomes 8x plus?
3.
Very good. And this is equals to?
0.
Very good. It's going to be 8. Jesus, look at that. Just one line and we get the answer. Because you can do this by inspection now. You take this, you multiply by that to get the 8. You reduce this by 1 to the first power. 8x, sir. Now 1 here is 1, and you multiply by 3 to get 3. You subtract 1 from 1, 0. Anything raised to the power 0 is 1. So, sir, this is 8x plus 3. What is, uh-oh. We didn't know so there's a trick to it, you know. Anytime class go nice, and we have got through so easy, sir, always put something in there but kind of just trickify it. It's not a matter of trickifying. I'm teaching you the chain rule. I'm teaching you the chain rule of differentiation. Think of the chain. Think of a chain. A chain has many links. Talk truth.
Yes, sir.
And when a little boy them on road see a nice, good chain, and them want pop off the chain off her neck. If it's just pop off the chain off her neck alone, that wouldn't be a problem. But they want pop off and gunshot you or pop off and knife you, right? But when them pop off the chain off her neck, you know what happened by the chain burst? You hear them have a saying that says the chain is as strong as its weakest link?
Yes, sir.
It is the weakest link in the chain that will break. It is the weakest of the links in the chain that will pop. All right. So whenever you get a question like this, we have done indices and logarithms. You CAPE students did indices last term. The business class students did indices last semester for pre-calculus. One over x to the 7 is the same thing as x to the -7. Talk truth.
Yes, sir.
And 3 over x to the 5th is going to be 3x to the minus 5. And then now, we're going to have this. X to the negative 7 plus 3x to the negative 5 minus 4x squared minus 6. And then we can go ahead and differentiate. Watch me. Negative 7 times 1 is negative 7. I'm subtracting 1 from the point. Now, when it becomes 6, because it's a negative 7, so negative 7 minus 1 is negative 8. And then negative 5 times 3 is negative 15. Negative 15x to the negative 6. Remember, you're subtracting a negative number. So negative 5 minus 1 is negative 6. And this is 2 times negative 4 is negative 8. So this is going to be negative 8x. And the differential of a constant is equal to 0. So you see how ugly that one looked? But you see how nicely it turns out? Really not difficult. Now, I need to show you some notation. You notice I said to you, y is equals to the function, therefore dy by dx. I'm differentiating y with respect to x. Dy by dx. So you see all of those with dy by, but this one here, I gave you fx. And when I differentiate, I get f dash of x. F dash of x. So I want you to right? So please note the notation given in this question. F dash of x is the same thing as the first differential. F double dash is the second differential. And dy by dx is also the first differential. I think I have the explanation right down here. F dash denotes the first derivative, similar to dy by dx. F double dash is the second derivative, and I can also denote it as d squared y by dx squared. F triple dash denotes a third derivative, and I could also denote that as d cubed y by dx cubed. All right? So I want you to be familiar with both notations. Both notations, very important. Both notations. All right. I'm going to give you, I know I have the answers there. I don't care. I want you to use a chain rule to differentiate this. I want you to write the question, and I want you to try it, and I want you to see if you get the same answers as I would have gotten here. And then we can move into the power rule. Please, I really want to get through the rules today. So let's work on that. I'll give you a couple of minutes, please. Start. Always stay.
Good, sir.
Very good, sir.
Very nice. Very nice. All right. What do I do? Everybody's okay?
Yes, sir.
Yes, sir.
All right. So I'm going to move on to the power rule now. So of course, when I get the first derivative of all of this to be okay, let us look at this one. Please note. F of x is equal to x cubed. The first differential, when I differentiate x cubed, I'm going to get 3x squared. When I differentiate 3x squared one more time, I'm going to get 6x, which is my second differential. And when I differentiate 6x one more time, I'm going to get 6. What if I differentiate? What if I find a fourth derivative? What would be my answer?
6.
Is it 6?
No, sir, never mind.
Okay, no, so tell me what it is then.
Then will it be 0?
It will be 0 because the differential of a constant is equal to
0.
0. Yeah, man. 0 because the differential of a constant is 0 every time. The differential of a constant is equal to 0 every time, so it will be 0. All right. All right. Give me half a second. I want us to look at the power rule in a few. Let me just sort myself out here. So I want us to look at the power rule and get ourselves sorted out. So just remember now, so there are several rules to the differentiation. We have the chain rule, we have power rule, we have quotient rule, and we have product rule. So my aim is to go through all those rules with you. I may not do all of the rules today, but importantly, is for you to understand the different rules of the differentiation. Very important. All right. Okay, now. So let me go through the which rule now? The power rule with you. Let me go through the power rule with you. Let me just get myself sorted out here. Hold on 1 second, please. All right, so the power rule. The power rule. Now, I want to look, I'm going to go through this example. I want to look clearly and closely at what it is that I'm doing. I'm giving you two methods. Now, my first method is this. It says y is equal to 2x plus 5 or squares. Y is equal to 2x plus 5 or squares. It says for me to find dy by dx. And to find the value of dy by dx. What is dy by dx, sir? It is the differentiation. It is the gradient. It is the slope. I was saying to the Cape students last night that when you're going to little school and they ask you to find the gradient and you're using y2 over y1 minus x2 over x1, it's really a differentiation that you're doing. You're finding the slope, the gradient at a particular point. All right, so let's go. Let me show you what is happening here. Watch me. Let me go to my spotlight. It's very important that I do this with you. So this 2 is going to multiply in front of here, just like we have been doing before. Nothing different. Nothing different. This 2 is going to be multiplying in front of here, like we have been doing. See the 2 here? Then I'm going to write back the full function. See here, 2x plus 5. Then I'm reducing the power by 1. 2 minus 1 is this one. What is important now for the power rule is that I must now differentiate the inside of the parentheses and multiply by all of that. And the differential of 2x plus 5 is going to be 2, because the differential of a constant is equal to 0, and the differential of 2x is going to be 2. So recall, times 2 is obtained from the differential of what is inside the parentheses. Very important. Please note that we are required to differentiate inside the parentheses. I'm repeating myself for emphasis. For emphasis, please note that we are required to differentiate the inside of the parentheses, hands down. We have to differentiate the inside of the parentheses. And I'm going to prove to you that you must do it. All right? Now, what we do next is to say 2 multiplied by 2 gives me 4 and 2x plus 5 to the first. Now, when it's written to the first power, I don't have to write it. It's understood. If the power is greater than 1, I have to write the power. But if it's to the first, I don't have to write it. So, I could leave this as my answer, but I could go another step. If you left this as an answer here, I wouldn't penalize you. Unless I say to you, simplify, something like that. But I wouldn't penalize you. 8 marks, you get full 8. But I could also say 4 times 2x is 8x and 4 times 5 is 20. So let me run through this one more time. This is saying 2x plus 5 all squares, find dy by dx. What I'm doing is differentiating. This is a power. So all you know is how can you identify the power rule? When you have a term that is raised to a power greater than 1. When you have a term, when you have a function that is an exponent and it is raised to a power greater than 1, then you know you have the power rule. You have to differentiate as if you are differentiating normally, but remember that you have to also differentiate the inside of the parentheses and multiply by what it is that you'd have got in order to complete the differentiation. All right? So I'm differentiating everything as it is so that this 2 comes in front of here, see here, so 2x plus 5, and I'm reducing it by 1, just as we have done before. Just as we have done before. You know your teacher loves to copy and paste, right? For emphasis. So I'm not going to disappoint you. Just as we have done before. Y is equal to x to the n. Dy by dx is going to be equal to n x to the n minus 1. This formulation you must know. So then we have to know the limit as h tends to 0 of f of x plus h minus f of x all over h. Yes, because that is first principles differentiation. When I'm differentiating the chain, when I'm differentiating my product, my quotient, and so forth, chain rule, my differentiation is going to be y equals x to the n, dy by dx is going to be equal to n x to the n minus 1 every single time. All right, let's go. My proof, which is really my method 2. My proof, which is really my method 2. I'm going to let y be equal to the function. Remember, whenever you get questions like these, you have to define what the function is, because if I only gave you 2x plus 5 squares, you can't differentiate it because you can't find f dash of x. Neither can you find dy by dx because it has no name. It has no name. All right? So let's go. So we have the same question. But what I'm doing this time now, I am expanding my parentheses. So 2x plus 5 all squares is the same thing as 2x plus 5 times 2x plus 5. 2x times 2x is 4x squared. 2x times 5 is 10x. 5 times 2x is another 10x. And 5 times 5 is 25. Always remember that your middle terms will always come out to be the same. So you add these two 10x's together and you get 20x. So I'm going to have 4x squared plus 20x plus 25. Now I have my chains. I move from the power rule to now the chain. And I'm differentiating. 2 times 4 is 8x plus 20. Are these two answers the same?
Yes, sir.
Okay, they are the same. Now, let me just caution you. This is just a proof. But let me caution you. Never will you go into an exam and they give you something as a power rule and you are going to expand to differentiate it. Because in expanding, you may make an error. In expanding, you may make an error. And once you make an error with the expansion, that is the end of the full marks for the question. And you may end up getting 0 out of the quest for the question. So wherever the power rule comes in, just apply the power rule. No, this side say you're going to do all manner something to convert it because you're going to convert it and you expand it, you spend 10 minutes with the question and the question only carry 3 marks. You can't spend 10 minutes on a 3 marker. You spend 10 minutes on a 10 marker and a 20 marker. All right? So that's what the power rule is. Do you see what I mean when I talk about the power rule? Do you understand it?
Yes, sir.
Yeah, man. So for the power rule, all we do is differentiate as per usual. The only additional step for the power rule is that you have to differentiate it inside of the parentheses and then multiply it throughout by it, right? So that's the only thing that is different. All right, and then now we go to the product rule. The product rule is going to be the first times the differential of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. Now, differentiation and differential are synonymous. So sometimes you hear me talk about differentiation, sometimes you hear me talk about differential. So it is the first times the differential of the second plus the second times the differential of the first. That's the formula. Sir, what do you mean by that? I will give you a product. Can you agree with me that this is a product? 2x squared is being multiplied by 5x plus minus 3?
Yes, sir.
So that's a product. You know when you see a product, when you see a chain. How do you differentiate between a product and a chain?
Sir, for product, you have the bracket.
Okay, very good. And the chain you have? Let me see if I say it right. The chain you have what? Talk to me, somebody. For the chain, what are you going to have? All right.
Is it linked, sir?
You're going to have the links, and the links will be either plus signs or minus signs. It's like how this one is pure plus sign. You could have pure minus sign too, and you can have a combination of plus or minus. It's just links, right? What are the links? Addition sign and subtraction signs. Those are the links. But for the product rule, you will see a multiplication. You may have some parentheses in there. Something being multiplied by something. That's the product rule. The power rule, you may see it have something in parentheses raised to a power higher than 1. Oh, then sir, them couldn't give you 5x minus 3 raised to the second power. Yeah. But that will still be the product rule. But inside of the product rule, I'm going to have a power rule also. Can you see that?
Yes, sir.
Yeah, man. So I'm taking it into stages. Let's go. So I have a first, I have a second. Now to differentiate the product rule, by the product rule, it's going to be the first times the differentiation of the second plus the second times the differentiation of the first. It's going to be the first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first every single time. All right, let's go. Keep students, you are getting a treat today. Let's go. Oh dear, let me do this. No, not that. This. All right, let's go. So you have the first, you have the second. Watch me, don't blink. Watch me. The first, you hear me call the first? Let the spotlight. The first, I write it back. Every time I call it, I write it back. So the first, I write it back. Times the differentiation of the second. You notice that I name which one is my first and I name which one is my second, so I don't get confused. So the first, I write it down. Times the differentiation of the second. Now when I differentiate the second, I'm going to get 5 because the differentiation of a constant is equal to 0. Times the differentiation of the second. Plus the second. So we call the second, so we go right back the second. Times now the differentiation of the first. When I differentiate the first, I'm going to get 4x. See it right here, so differentiation done. Now, let me just pause you and say something. Those of you who did additional math and would have worked with differentiation before, and those of you who may be repeating business calculus and have done differentiation before, I guarantee you 100% that this is not how your teacher taught you differentiation. Is it the same way they taught you differentiation? It's the same way my teacher taught me differentiation. But guess what? Years ago, I came across my little story. The first times the differentiation of the second plus the second times the differentiation of the first. Never left me. And when I do the differentiation question, I sing a song to myself. The first times the second plus the second times the first. Good to go. Can't get it wrong. Cannot get it wrong. I remember some years ago at the college, I had a very good AdMath student. Saw her recently doing very well. She's at UTech now, finishing off our electrical engineering degree. And she was doing pure maths at the same time. No, I was teaching her AdMath and somebody is teaching her pure maths. And the person taught her pure maths using the other method of differentiation. And I use this method. And she said, sir, I prefer your method. And my home girl went into the exam and she got distinctions for both pure math and AdMath. She said, sir, I love this method. Love it. So it is an easy method. You don't have to worry too greatly about it. If you know another method and you prefer that method, it doesn't matter. I also know the other method. All right, so let's go. Going through the question again. Differentiation ends where I have it in blue, but let me go through that part. The first, 2x squared, times the differentiation of the second. When I differentiate the second, I'm going to get 5. Plus the second, I write it back, the second, and then I times it by the differentiation of the first, which is going to be 4x. All that is left for me to do now is algebra. 2x times 5 is going to be 10x squared. 2x squared times 5 is going to be 10x squared. And then 4x times 5x, when I multiply x by x, I get x squared. So 20x squared, sir. Very good. See there? And negative 3 times 4 is negative 12x. All I need to do is just put them together. 10x squared plus 20x squared is 30x squared minus 12x. Good to go. But guess what? What did the question say? Simplify your answer. Simplify. Carry it down to its lowest term. You cannot factorize something. But if you left it right here, so you still get the same number of marks, depending on what the question asks you. You don't have to worry too greatly about it. And with that said, looking at the product rule, I have me another example that I'm going to ask you to try on your own now. We have 10 minutes left. Let us see if we can finish off this part of the question. So start working for me, please. Thank you.
Sir, what is 7 months now?
Example number 2. I want you to look at the first. You're not seeing it?
No, scroll up some more.
Anybody seen it?
Yes, sir, I'm
No,
seeing
sir.
it.
No, sir.
You know, it's just that my answer don't just say that's it.
The
All right,
black
let me just.
part for the Zoom cover mine.
All right, hold on. We don't want you to see me answer. That's why.
Yes, sir,
All right,
that's
the answer.
it. Yes, sir.
Good job. Anybody finish?
Then we have something about me.
And that's fine. And that's fine. And what have you tried?
Then we get 12x times 2 to the 2x to the 4th power minus 3x.
Anybody got what Aniki got?
No, sir. Sir, I got 24x to the 5th minus 36x squared.
Yeah, I
Anybody
get
got what?
then I factorize it. I'll get 12x times. Yeah.
Anybody got this?
Then what that means? We just put 12x at 2 times x to the 4 minus 3x.
What you say? Put tell me again.
12x times 2 to the x 4th power minus 3x.
Okay, but that means you wouldn't have, it's not incorrect, but you wouldn't have completely factorized the question. So
Yes,
think of it this way.
like,
Right, think of it this way. You can't eat and just half eat something. If you're really hungry, you can't just take a bite of a burger and say you're belly full. Eat all the burger. And the truth of the matter is, if you eat a burger, better just drink one soda with it and drink one milkshake, because eating the burger is already sin. So it don't make sense to half sin. If you have a half sin, just full sin and done. We're not supposed to sin, you know. But it don't make sense to try half do something and feel good. So if you're gonna eat a burger, just eat one burger and drink one soda and wash it down. Or drink one milkshake and wash it down. Okay? So go ahead and just do the complete stuff. All right, I have 4 minutes. Let's go. My first, my second. My first, my second. It's the first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. First times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. Very important that this piece here is a plus. So it's the first times the differential of the second plus the second times the differential of the first. Always very important that you find that out. So the first, times the differentiation of the second. Now I need to differentiate the second. The differential of a constant is equal to 0. So I'm just going to differentiate my x cubed. I'm going to get 3x squared. See it right here, so finish differentiating the second. So I'm going to say plus, see it here, so plus the second. I'm going to write back the second. And then I'm going to multiply it now by the differential of the first. So I need to differentiate the first. Differentiating the first, 3 times 4 is 12, 12x squared. See it here, so 12x squared. In blue ends my differentiation. Blue ends my differentiation. All I'm left with now is some algebra. I'm left with some algebra. And when I'm left with some algebra, what I'm going to be doing is to simplify so that I can come up with my final answer. I'm going to simplify it so I can come up with my final answer. So this 4x cubed times 3x squared. 4 times 3 is 12. And x cubed times x squared is x to the 5th power. So 4x cubed times 3x squared is going to be 12x to the 5th. 4 times 3 is 12, and x cubed times x squared is x to the 5th. And then 12x squared times x cubed is going to be 12x to the 5th. Remember, when you're multiplying and the bases are the same, you add your powers. 3 plus 2 is 5. And 12x squared times negative 3 is going to be negative 36x squared. So this is a first step of my simplification. Then I'm going to add these two terms because they are the same parent, x to the 5th. I can't subtract it from this because this is a different parent, x squared. So 12x to the 5th plus 12x to the 5th is 24x to the 5th minus 36x to the second power. And I can end it right here, or I can go and simplify. All right, I thank you for coming out. We had a rough start. And I keep telling you that it's a Saturday morning and I don't want to start rough because it may put our damper on the remainder of the class. Thankfully, it didn't. We've gotten to a very far stage in the differentiation. I'm going to send you off the stuff, business calculus. My other students, I will share the recording. When I post the recording for the business calculus differentiation, you can watch it. That much I can do for you. And then you can see all of what it is that we have here, the handout here in it. So I'm gonna, hopefully I get a recording before the day ends. As soon as I get a recording, I'm gonna post it. And I'm gonna finish posting so I'll let you know so you can re-watch it and you can see the questions here. All right? Thanks for coming out and have a good one.
Bye, sir.
You too, sir.
Bye, sir.
Cool.
Okay, sir.
Yeah, man.